Welcome to Unacademy Ascend YouTube channel. This is Umamaheshwar Rao. Unacademy is conducting All India mock tests for GATE 2022. Complete your final revision for GATE with All India mock tests for GATE 2022. Every Sunday from January 2nd to January 30th. The questions are prepared by the top educators. Cover your entire syllabus. Experience actual exam like setting. Get your All India ranking. Identify the areas of improvement with detailed analysis and video solutions. Access your GATE preparation at All India mock test for GATE 2022. It is a revision test for GATE aspirants every Sunday from January 2nd to January 30th. Unacademy's GATE Mega Combat in Mechanical Engineering, Civil Engineering, Electrical Engineering, Electronics and Communication Engineering, Computer Science and Information Technology. 60 minutes, 20 questions, January 30th at 11 a.m. Unacademy's Mega Combat in Mechanical Engineering, Civil Engineering, Electrical Engineering, Electronics and Communication Engineering, Computer Science and Information Technology, January 30th at 11 a.m. Unacademy is announcing new batches for GATE 2023 and 24 in Electrical Engineering, Electronics and Communication Engineering, Chemical Engineering, Evolve batch for GATE 2023 and Ascend batch for GATE 2024. Spark batches for GATE 2023 and Varu batch for GATE 2024 in Electrical Engineering and Electronics and Communication Engineering. Welcome to the revision course on Engineering Mathematics, Complex Variable. The residues at simple poles of f of z equal to 7 minus 3z by z square minus z are f of z is 7 minus 3z by z square minus z, that is a by z, b by z minus 1. Put z equal to 0. 7 minus 0 by 7 minus 0 by 0 minus 1, that is minus 7. Minus 7. Put z equal to 1. 7 minus 3 by 1. 7 minus 3 is 4. Now, residue of f of z at z equal to 0 is minus 7. Residue of f of z at z equal to 1 is 4. This is residue of f of z at z equal to 0. This is residue of f of z at z equal to 1. So minus 7 and 4. Next problem. Let P of z is a0 plus a1z plus an z power n. Q of z is b1z plus b2z square plus bnz power n. If a0, b1 are non-zero complex numbers, then residue of P of z by Q of z. See here, residue of P of z by Q of z at z equal to 0 means at z equal to 0, P of 0 is non-zero, but Q of 0 is 0. Numerator non-zero, but denominator is 0. That's why residue of P of z by Q of z at z equal to 0 is limit z tends to 0, P of z by q dash z, because numerator is non-zero but denominator is 0. P of 0 is non-zero but q of 0 is 0. That's why. Now limit z tends to 0. P of z you write as it is. P of is a naught plus a1 z plus an z power n by differentiation of denominator b1 plus b2 into 2z, b1 plus b2 into 2z plus and so on, bn into n z power n minus 1. When z is tending to 0, numerator is a2, denominator is b1. So a naught by b1, a naught by b1 is the answer. So the residue of P of z by q of z at z equal to 0 is a naught by b1. Next problem. Find the residue of f of z equal to 1 minus cos z by z. The residue of f of z equal to 1 minus cos z by z. So denominator z equal to 0. Now residue of 1 minus cos z by z at z equal to 0 is limit z tends to 0. Here when z equal to 0, numerator is 0, denominator is also 0. That's why z minus 0 into function of z, z minus 0 into function of z, 1 minus cos z by z, z cancel, limit z tends to 0, 1 minus cos 0, 1 minus 1, that is 0. Residue of f of z at z equal to 0 is 0. So 0 is the answer. Let R be the circle given by z equal to 4 into e power I theta, 4 into e power I theta, where theta varies from 0 to 2 pi. Then e power z by z cube minus 2z, z equal to 4 into e power I theta. Therefore, mod z equal to mod 4 into e power I theta. Mod e power I theta is 1. That's why mod e power I theta is 1. That's why mod z equal to 4. Mod z equal to 4. Therefore, a circle with center 0 and radius 4. A circle with center 0 and radius 4. Now, e power z by z cube minus 2z, integral e power z by z cube minus 2z, dz, e power z by z cube minus 2z. Now, if you take z common in denominator, e power z by z of z square minus 2, So z equal to 0, this is mod z equal to 4, therefore boundary points are 4 and minus 4. See, z equal to 0 lies inside, z equal to plus or minus root 2 lies inside, therefore you have to calculate residue at 0 and residue at plus root 2, residue at minus root 2. Residue at 0, residue at plus root 2, residue at minus root 2. Now all lies inside. Now residue of f of z at z equal to 0 is limit z tends to 0, z minus 0 into e power z by z cube z square minus 2. Z cancel. When z is tending to 0, e power 0 is 1, 0 minus 2 is minus 2. So minus 1 by 2. Next, a residue of f of z at z equal to plus root 2, limit z tends to 0, z minus root 2 into e power z by z minus root 2 into z plus root 2 into z. Z minus root 2, z minus root 2 cancel. E power 0 is 1. 1 by getting 0. That is infinite. This is, the problem is 1 by, it is z cube minus 2z square. If z cube minus 2z square comes, you can take z square, here z minus 2, z equal to 0 is pole of order 2, the problem is z square of z minus 2. Z equal to 0 lies inside, z equal to 2 also lies inside. Z equal to 0 is a pole of order 2, that's why you apply pole of order 2 logic. Correction is there here, z cube minus 2z square. The residue of f of z at z equal to 0 is limit z tends to 0, 1 by 1 factorial into d by dz of z square by e power z by z square of z minus 2. Z square cancel. When z is tending to 0, 1 by minus 2. E power 0 is 1, 1 by minus 2. Now, here you have to differentiate. That's why limit z tends to 0. Denominator is z minus 2 whole square. Numerator is z minus 2 into e power z minus e power z into differentiation of z minus 2. When z is tending to 0, minus 2 into e power 0 that is minus 2, minus e power 0 is 1, by 0 minus 2 whole square is 4, that is minus 3 by 4. Residue of f of z at z equal to 0 is minus 3 by 4. Next, residue of f of z at z equal to 2 is limit z tends to 2, z minus 2 into, because it is simple pole, e power z by z square of z minus 2, z minus 2, z minus 2 cancel, that is e square by 2 square 4. Therefore, the value of integral is 2 pi I into sum of residues. One residue is e square by 4. Another residue is, residue at z equal to 0 is minus 3 by 4. Minus 3 by 4. That is pi I by 2 of e square minus 3. Pi I by 2 of e square minus 3 is the answer. Next, the residue of f of z, z square into sine 1 by z at z equal to 0 is, now f of z is z square into sine 1 by z, z square into sine 1 by z at z equal to 0, 1 by z minus 1 by z cube by 3 factorial. One by z minus 1 by z cube by 3 factorial plus 1 by z power 5 by 5 factorial, 1 by z power 7 by 7 factorial, and so on. That is z square into 1 by z is z, z square by z cube is 1 by 3 factorial into z, z square by 1 by z square by z power 5 is 1 by 5 factorial into z cube minus 1 by 7 factorial into z power 5 and so on. Now residue is nothing but coefficient of 1 by z. Therefore, residue of z square sine 1 by z at z equal to 0 is coefficient of 1 by z, that is minus 1 by 3 factorial. So correct answer is minus 1 by 3 factorial, minus 1 by 6. If mod z minus 1 equal to 2, then z bar minus z bar is, given that mod z minus 1 equal to 2, mod z minus 1 whole square equal to z minus 1 into z bar minus 1 equal to 4, z bar minus z bar plus 1 equal to 4. Therefore, z bar minus z bar equal to 3. Therefore, the value of z bar minus z bar equal to 3. So finally, 3 is the answer. The principal value of log I power 1 by 4 is, log I power 1 by 4 that is nothing but I means e power I pi by 2. Power 1 by 4. Now e log e power I pi by 8, that is nothing but I pi by 8. Because magnitude of I is 1, r value 1, theta value pi by 2. Therefore, if you write in polar form and exponential form, r into e power I theta, r into e power I theta is nothing but 1 into e power I pi by 2. That is nothing but e power I pi by 2. Therefore, e power I pi by 2 is nothing but I power 1 by 4. So e power I pi by 2 whole power 1 by 4. That is I pi by 8. So the principal value is I pi by 8. Next one. Sin z equal to sigma n equal to 0 to infinite a6 into z minus pi by 4 whole power n. Then a6 equal to, so z minus pi by 4 whole power 6. Then a6 is, we have to calculate a6. So we have expressed sin z in terms of z minus pi by 4 whole power n. In terms of z minus pi by 4 whole power n means we have expressed into Taylor series expansion form. If you express f of z into Taylor series expansion form, what is a6? Now, a6 is nothing but sixth derivative of f at pi by 4 by 6 factorial. So I have to calculate sixth derivative of f at pi by 4. Now, sixth derivative of f at pi by 4 by 6 factorial. 6 factorial is 720. So first I have to calculate sixth derivative of f at pi by 4. Now f of x is sin x. F dash x is cos x. F double dash x is differentiation of cos x minus sin x. F triple dash x is differentiation of minus sin x is minus cos x. Fourth derivative of f is differentiation of minus cos x is sin x. Now fifth derivative of f is differentiation of sin x is cos x. Now sixth derivative of f is differentiation of cos x is minus sin x. Now sixth derivative of f at pi by 4 is minus 1 by root 2. Now if you substitute here minus 1 by root 2, you will get minus 1 by root 2 by 720. That is minus 1 by 720 root 2. Minus 1 by 720 root 2 is the correct answer. Last option. Next problem. Find the residue of f of z at z equal to 1. F of z is 5z minus 2 by z into z minus 1. Now residue of f of z at z equal to 1 is, z equal to 1 is a simple pole. That's why residue is given by limit z tends to 1. Z minus 1 into 5z minus 2 by z into z minus 1. Z minus 1 you can cancel. When z is tending to 1, 5 minus 2, 3 by 1, that is 3. Finally, the value of residue at f of z is at z equal to 1 is 3. Next problem. If omega is analytic, then what are the values of A and B? Omega is analytic, then what are the values of A and B? U is x square minus y square minus ax plus y plus 2. Now ux is 2x minus a. Now v is 2xy minus 5y minus bx. 2xy minus 5y minus bx. Now vy is 2x minus 5. Therefore a is equal to 5 because ux equal to vy. By using this CR equation, we can identify the value of a is 5. Next, another CR equation, uy. If you calculate uy is minus 2y plus 1. vx is 2y minus b. Therefore uy equal to minus vx. Therefore b is equal to 1. A is 5 and b is 1. You have to calculate a value and b value. A is 5 and b is 1. So the correct answer is a is 5, b is 1. Now here the function f of z equal to z bar. F of z equal to z bar. Z is x plus iy. Z bar is x minus iy. X plus iy into x minus iy is x square minus I square y square. X square plus y square. U plus iv is x square plus y square. U is x square plus y square. V is 0. Now ux is 2x. Uy is 2y. Vx is 0. Vy is 0. Now at 0 comma 0, CR equations are satisfied. But at 0 comma 0 CR equations are satisfied, but in the neighborhood the CR equations are not satisfied. So the function satisfies both the conditions of Cauchy-Riemann theorem at the point 0 comma 0 but not in its neighborhood. Therefore f of z is derivable at 0. Derivable at 0 comma 0 but not analytic at 0 comma 0. But not analytic. So the function is not analytic at any point, but it is differentiable at 0 comma 0. So nowhere analytic is the correct answer.